Completing a square is one of those things that, I guess, it's not always exactly obvious why you need it, because pretty much the next thing I'm going to do is teach you the quadratic formula. But nonetheless, it's one of those really important things to know, I guess, theoretically, because that's how the quadratic formula is actually derived. So, let's start off with something basic. If I gave you that x squared was equal to 9, could you tell me some values for x? Probably you immediately say, okay, well I know that x is 3, but would you also come up with that x is negative 3, right? Because if I square negative 3, I'm still going to get 9. So whether I square 3 or square negative 3, I'm going to get 9. Now in your brain, whether you thought about it or not, what you did is you took the square root of both sides of this equation. But one of the things you have to do is when you physically impose a square root on a problem, you need to add a plus or minus in front of the square root sign. And that means, hey, I stuck the square root sign in here. I'm not really sure if I was supposed to. Well, I was probably supposed to, but I just want you to know that there's probably this plus or minus thing going on. So what this comes out to is, remember that the square root of x squared is x. So you have plus or minus the square root of 9, which is plus or minus 3. And that's how algebraically you would get plus 3 or minus 3. Okay? Similarly, if I had something like, x squared is 50, that might be something you can't necessarily do in your head, but you can solve it the same basic way. So you take the square root of both sides and you put the plus or minus in front of one of the sides. So you have that x is equal to plus or minus the square root of 50. We can separate that out into 25 and 2 to get, eventually, x is equal to plus or minus 5 square root of 2. Okay, so your solutions are 5 square root of 2 and minus 5 square root of 2. Right. Now I do want to take a quick moment to show you that if you're given a problem that says x is equal to the square root of 9, that literally means x is equal to the square root of 9, which is 3. If you're given a problem that says x equals the negative square root of 9, again, quite literally, that means negative square root of 9, which is 3. The only time you're going to get that plus minus is if you have a problem that looks like this, and you are the one who physically goes in and puts in the square root. If you are the person putting in the square root sign, then you are responsible for advocating for both of those solutions. Okay? And kind of one way maybe to remember it, if this is helpful, is remember that you have that secret 1 up there. Generally, if you have an x to the first, that means you have one solution. So again, you have x to the first, so that really means you have one solution. But here we have x squared in the original problem. That generally kind of means that we have two solutions. Now they can be repeated solutions, but that's neither here nor there. So when you look at that, you want to remember, okay, that's x squared, that probably means I have two solutions. So let me make sure I have a plus 3 and a minus 3. Okay? Now try to do this one in your head. If I said the square root of x plus 1, oh, that's not what I meant. If I said that that equals 9. Now could you come up with something? Could you come up with that just by looking at it? Maybe. The square of x plus 1, oh, try this again. X plus 1 squared equals 9. Well, in your head, you might say, well, I know that x squared equals 9 has 3 and negative 3. Maybe if you're really good, some people are just really good at staring at these and getting it. Some people can look at this and maybe at least get the x equals 2, because they say, okay, well, 2 plus 1 would be 3. If I square it, I'll get 9. Now, if you're really clever, and I actually am not sufficiently clever to do this, you might also get negative 4. Because you could say, oh, negative 4 plus 1 is negative 3, and if I square that, I get 9. But we're already getting into the realm of problems that most people have no desire to do in their head. Okay? So generally we have a problem like this, and I'm just going to rewrite it so you can still see the original problem there, is again, if you have something squared equals some number, I want to take the square root of both sides and put that plus or minus out front. So on the left, I'll have x plus 1, and on the right, plus or minus 3. Now at this point, you're going to need to break this up into two separate places. So you have x plus 1 is equal to positive 3, or x plus 1 is equal to negative 3. Okay? And I can solve these that and get x is equal to 2 or x is equal to -4. And those are the same solutions that we just got up here. And actually, on these problems, both of those solutions are going to be completely acceptable. We're going to keep both of them. Okay? We're getting up to completing a square. I'm just kind of giving you the stuff you need to complete the square well. Hopefully if I explain all this, then we get to completing the square, it'll make more sense. Okay, so now, let's say we have something a little bit more complicated. Like that. Okay? I want to get the squared term by itself, so I want to get all the x's by themselves. So let's go like this, and I'll have x squared is equal to 7. And if I take the square root of both sides, I'll get that x is equal to plus or minus the square root of 7. Okay? About all else I could do is something like, I don't know. I'm going to get the same answer, that's okay. Let's change it to that. Okay? So really all we're going to do here is we're just going to manipulate it to get the squared term by itself. Divide both sides by 3. X squared equals 5. And again, take the square root of both sides, the plus or minus out front, and get that x is equal to plus or minus the square root of 5. So depending on if you're doing this on the computer, your software is either probably going to want you to do it, maybe want you to do it like this, list each of them separately, or it might have a plus minus button. I don't know if my math lab has a plus minus button on certain editions. So there you go. Okay. Now, about the only other thing I can do to try to introduce you to this, I'll give you maybe 2 more problems. I'm trying to work up to it slowly. So let's do something like this. Like that. Okay. All right. So remember, we're going to get the square thingy by itself. Then I want to take the square root of both sides with my little plus or minus out front to get 2x minus 5 is equal to plus or minus the square root of 16, which is 4. Now I'm going to have to break it down into 2 separate parts. Equals plus 4 or 2x minus 5 equals minus 4. Add my 5 to both sides. And then divide both sides by 2. And I've got x equals, x equals 9/2 or x equals 1/2. And those would be both of my answers. Okay? Now, I guess one more step toward completing the square would be to show you a problem like this. If I have x squared plus 2x plus 1 equals, I don't know, 25. All right. Now, I want you to just trust me on this. We're going to leave the 25 where it is. I want you to factor what we have on the left, like this. Okay, and there's a reason for this. All right, so we're going to put the x here. They're both pluses. And hopefully without too much effort, you can get x plus 1 times x plus 1. Now we can write this as x plus 1 quantity squared is equal to 25, right? You see now where we're going with this? Maybe? Maybe not. Take the square root of both sides, add my plus or minus out front, x plus 1 plus or minus the square root of 25, which is 5. And again, we'll break it up. X plus 1 equals 5. X plus 1 equals minus 5. Minus 1, minus 1, minus 1, minus 1. So I have that x can be equal to 4 or negative 6. Okay. And again, if you're not solving these that fast, don't worry about it. We're not going for speed. I've actually been doing this for a considerable amount of time now. So, you know, we're not getting judged on speed. It's more on comprehension. So if you need to pause the video and go back and rewatch something a million times to make it make sense, you know, go for it. But everything that we did here needs to be kind of, sort of, reasonably okay before we move on to actually completing the square.